Let's go now over the specific cases that have -5 instead of just 5. Michigan will be helping us with these examples. The first one I'd like to go over is -5 plus 2. So Michigan will be at -5. She's going to look forward. She is going to look towards positive infinity because of the plus sign, because she is adding using addition. Then she's going to move forward from her perspective 2 steps because 2 is positive. 1, 2. She sees where she lands at, and it is at -3. I would like to further explain why -5 plus 2 is equal to -3. To do so, I'd like to provide an example that we did earlier, 5 minus 2, and see how it's similar and different from -5 plus 2. For -5 plus 2, Michigan would be at -5. For 5 minus 2, Arizona would be at 5. So to note, their positions, their starting places, are opposite. You can think of 0 as like a mirror. To add to, Michigan is adding and therefore is facing towards positive infinity. Arizona, however, is subtracting and facing towards negative infinity. Both of them are moving 2 steps forward based on their own perspective. 1, 2. Because their starting places are opposite and the actual movements they do are opposite, as Arizona was moving towards negative infinity and Michigan was moving towards positive infinity, it makes sense that their landing places are opposite. Michigan lands at -3 and Arizona lands at 3. So you can think of -5 plus 2 as equivalent to negative parentheses 5 minus 2, which you can simplify as -3, which is easily written as -3. So this is how you solve -5 plus 2 or similar problems without using rulers, without using number lines. But I use rulers and number lines to show why does it make sense. So how to remember that -5 plus 2 equals negative parentheses 5 minus 2? One way to do so is to think of the distributive property. Right now, it might be harder to remember it this way if you have not heard of the term before, but later this is how you remember it, because this is one aspect of the distributive property. The distributive property normally has 2 equations. One of them is x times y plus x times z equals x times parentheses y plus z. So that means that x is one number, y is another number, and z is yet another number. Whatever numbers you choose, this equation will still hold true. Another one, and what is probably based from the first equation, is x times y minus x times z equals x times parentheses y minus z. On the right equation, z is the opposite from the left equation. That means that z from the right equation is equal to negative z from the left equation. So how can you get -5 plus 2 equal to negative parentheses 5 minus 2? You can rewrite -5 to be -1 times 5. So you still need a plus sign because the equation has a plus sign. And then you can rewrite 2 as -1 times -2. You still need an equal sign because that's what the formula from the left side has, or the equation from the left side has. You can think of negative of everything as -1 times everything. We have the parentheses from the left equation again. We have 5 and then plus -2, and we are shown in this video that 5 plus -2 is equal to 5 minus 2. We have plus a negative because in the formula there's a plus sign for the left equation, and then we end our parentheses. So for this, x is equal to -1, y is equal to 5, and z from the left equation is equal to -2. And you can see that this equation is based on the distributive property. Also, you can see that it works for the right equation as well. So instead of the plus sign, we'll have a minus sign. But we still need the same value. So instead of -2, we're going to have 2. Then again, we have a minus sign instead of the plus sign. But we still need the same value, so we'll have a 2. So in this case, z is equal to 2 for the right equation. So as you can see, maybe not now if you have not heard of the distributive property beforehand, but later, this is how you remember that -5 plus 2 equals negative, parentheses, 5 minus 2 is because of the distributive property. I would now like to discuss -5 minus 2. So Michigan will be at -5. She will face towards negative infinity because she is subtracting. She is facing backwards. She is moving forward based on her perspective because 2 is positive. 1, 2. She sees where she lands at, and it is at -7. So -5 minus 2 is equal to -7. I would like to further explain why -5 minus 2 is equal to -7. To do so, I would like to provide another case that we did earlier and see how it's similar or different. For -5 minus 2, Michigan would start at -5. Arizona, for 5 plus 2, will start at 5. So you can see that their positions are opposite. Arizona, for adding, will have to face towards positive infinity. Michigan, for subtracting, will have to face towards negative infinity. So yes, they're facing, the way that they face is opposite. But what's really important, other than where they start is opposite, is that how they really move is opposite. Both of them move 2 forward based on their own perspective. 1, 2. In reality, they're moving 2 in opposite directions. Because they start in opposite places and move in the same amount in opposite directions, it makes sense that they end up in opposite places. Michigan lands at -7 and Arizona lands at 7. So you can think of -5 minus 2 is equal to -5 plus 2, which simplified would be -7, or simply -7. Let's now talk about -5 plus -2. So Michigan would start at -5. She would face forward. She would face towards positive infinity because of the plus sign, because she is using addition. However, she will walk 2 steps backwards based on her perspective because of -2. 1, 2. She sees where she lands at, and it is at -7. So -5 plus -2 equals -7. I want to talk a little bit more about how could you solve -5 plus -2 without using rulers. So for this problem, Michigan started at -5. She faced forward, she faced towards positive infinity. However, she walked 2 steps backwards based on her perspective because of -2. 1, 2. So ultimately, she walked towards negative infinity. This is similar to when she was at -5 facing towards negative infinity, but walking forward based on her perspective. 1, 2. In both cases, she has the same starting place. She is walking towards negative infinity. So negative 5 plus negative 2 equals negative 5 minus 2. And we already shown that this is equivalent to, based on a distributive property, negative 5 plus 2, all in parentheses. And you can simplify that as negative 7, or simply negative 7. So negative 5 plus negative 2 is equal to negative 7. Let's now talk about the hardest example and our last example, negative 5 minus negative 2. So Michigan would be at negative 5. She would be facing towards negative infinity because of the minus sign, because she is subtracting. She'll be walking backwards based on her perspective because of negative 2. 1, 2. She sees where she lands at, and it is at negative 3. So negative 5 minus negative 2 equals negative 3. Let's now talk about how you can solve negative 5 minus negative 2 and other similar problems without using rulers, without using a number line. To solve this, Michigan started at negative 5. She faced backwards. She faced towards negative infinity. She also walked backwards because of negative 2. 1, 2. And so ultimately, she started at negative 5 and she moved 2 steps towards positive infinity. So this is the same as negative 5 plus 2. And we already seen that that is equivalent to negative parentheses 5 minus 2, and you can simplify that as negative 3, or simply negative 3. So negative 5 minus negative 2 equals negative 3.
The next and last part of the series of videos is about a summary of all the rules that we just discovered. Attached is a link that you can click if you would so wish.